Hello students, my name is Alok Semwal and in today's lecture I am going to discuss about introduction, classification, mode of action and structure activity relationship of local anesthetics. Drugs classified as local anesthetics inhibit the conduction of action potentials in all afferent and efferent nerve fibers. Afferent neurons convey the sensory stimulus to the brain. The efferent neurons convey the motor stimulus to the muscles. For example, if our hands start burning in the heat of any candle, the afferent neurons will convey this sensory stimulus of burning sensation to our brain. And the efferent neurons will convey the motor stimulus, and thus we will start moving our hand away from the candle. Now, because local anesthetic inhibit the conduction of action potentials in afferent and efferent nerve fibers, the final effect will be that pain and other sensations are not transmitted effectively to the brain, and motor impulses are not transmitted effectively to muscles. Local anesthetics have various clinical uses to treat acute or chronic pain or to prevent the sensation of pain during surgical procedures. Classification of local anesthetics include four main categories. First category is benzoic acid derivatives. Drug candidates in this category are cocaine, hexylcaine, meprilcaine, cyclomethicaine, and piperocaine. Second category is of amino-benzoic acid derivatives. Drugs in this category are benzocaine, butamben, procaine, butacaine, propoxycaine, tetracaine, and benoxynate. Third one is lidocaine or analyte derivatives. It includes lignocaine, mepivacaine, prilocaine, and etidocaine. Last category is of miscellaneous agents. This category includes phenacaine, diperodone, and dibucaine. Following are the structures of benzoic acid derivatives. These are amino-benzoic acid derivatives. Lidocaine analyte derivatives. And miscellaneous agents. Next is mode of action of local anesthetics. So before starting mode of action, we have to understand conduction of nerve impulses. This diagram is showing action potential generation along axon. Conduction of nerve impulses is mediated by action potential generation along axon. As an action potential which is in the form of nerve impulses travels down an axon, it causes change in polarity across the axon membrane. In response to a signal from another neuron, gated ion channels such as sodium and potassium open and close as the membrane reaches its threshold potential. In the beginning of the action potential, sodium channel open and sodium moves into the axon. Result of this movement is depolarization. Now next step is repolarization, in which the potassium channel open and potassium moves out of the axon. This creates a change in polarity between the outside of the cell and the inside. Thus the nerve impulses travels down the axon in one direction only. The nerve impulse travels down the axon towards the axon terminal where it signals other neurons. Now, mode of action of local anesthetics. The mode of action of local anesthetics is believed to be via their sodium channel blocking effect. The local anesthetic drug binds to the channel in an area just beyond the selectivity filter or P region. When the local anesthetic binds, it blocks sodium ion passes into the cell and thus blocks the formation and propagation of the action potential. This blocks the transmittance of the message of pain or even touch from getting to the brain. The ability of a local anesthetic to block action potentials depends on the ability of the drug to penetrate the tissue surrounding the targeted nerve as well as the ability of the drug to access the binding site on the sodium channel. Next is structure-activity relationship of local anesthetics. All local anesthetics have three structural features in common. First one, an aromatic ring which is usually substituted. Second one, an ionizable amino group. And third one, a connecting group which is either an ester or an amide. It is also called as a linker group. The substituted aromatic ring side of local anesthetics is the lipophilic portion of the ring. Ionizable amino group denotes hydrophilic portion of the ring. And connecting group or linker which connects lipophilic portion and hydrophilic portion of the ring is an intermediate chain of either ester or an amide. First portion is lipophilic portion. Lipophilic portion is essential for activity. Preferred groups at this position are benzoic acid and para-aminobenzoic acid. The carbonyl group must be in conjugation with aromatic nucleus. This is confirmed by the fact that reversed esters have no local anesthetic activity. Introduction of electron donating groups at ortho or para positions of the ring increases conjugation and binding of drug to the receptor, prolonging the action time. For example, NH2 group in procaine and an alkyl amino group in case of tetracaine increases electron density to the aromatic ring by both resonance and inductive effects, while the opposite occurs in case of electron withdrawing groups such as NO2, CO, and CN. Second portion is the intermediate chain. The intermediate chain is alkyl chain of amino alcohols involved in the esters. The propylene group provides the most active compounds. Next, ethylene, while methylene group makes the compound too irritant. The branching with small alkyl groups around the ester function, as in case of maprilcaine, hinders esterases catalyzed hydrolysis, which results in increase in duration of action. Last portion of the structure is the hydrophilic portion. It is amine part of amino alcohols used to esterifies aromatic acids. Its advantage is its ability to form salts with inorganic acids, producing water-soluble compounds. Thank you.